Welcome to In 5 Minutes. We take problem on deflection of beams, and in this we take problem on simply supported beam with UDL. A problem statement is determine slopes at supports and deflection at other points for the beam as shown in the figure. So this is a loading diagram of the beam which is given. Also find maximum slope and its position. Take EI, which is flexural rigidity, as constant. So we have this loading diagram of the beam. We have two supports at the extreme ends, a hinge support over here and a roller support at the other end. And we have a UDL of 12 kN per meter for length of 3 meter. Then we have a clockwise moment of 24 kN meter at a distance of 5 meter from the left end, and a downward vertical force of 30 kN at this point, which is at a distance of 2 meter from this end. So let us first name all the salient points. Let this be point A, this be point B, C, D and E. Let us also show the support reactions at point A and E. We'll assume a vertical support reactions at both the supports. So let this be VA and let this be VE. In the problem, a given data is flexural rigidity EI is some constant whose value is not provided. And in this problem, we have to find slopes at supports. That means we have to find theta at point A, which is a hinge support at the left end. Then next, theta at point E, which is a roller support at the right extreme end. And we have been also asked to find the deflection at other points of the beam. That means you have to find deflection at point B, YB, then deflection at point C, YC, and deflection at point D, YD. And finally they have asked to find the maximum slope and its position. So we have the last thing is maximum slope, that is theta max, and its position, meaning that the location of the point where your slope is maximum from some reference point, either the left hand support A or the right hand support E. So let's solve the problem. So we start with the solution. Our first step is to find out the support reactions VA and VE. Now we make use of static equilibrium equation, which is summation of moment about any point equal to 0 and summation of Fy is equal to 0. So we take the first static equilibrium equation and we apply it at point A. So we have summation of all moments of forces about point A is equal to 0. Writing the moments of all the forces about point A, we have a sign convention is clockwise moment is positive, anti-clockwise moment is negative. So we have the first clockwise moment due to this UDL of 12 kN per meter intensity, which is acting for a distance of 3 meter. So we have 12 into 3, which is the magnitude of force, and this UDL is acting at a distance of 1.5 meter, that is at the center from your point A. Then we have a clockwise moment or couple of 24 kN meter, so plus 24. Then we have a clockwise moment due to this downward vertical force 30 kN, which is acting at a distance of 3 plus 2 plus 2 is 7 meter, so we have plus 30 into 7. Then we have an anti-clockwise moment caused due to this vertical support reaction VE, which is upward, acting at a distance of the whole span of beam, which is 9 meters. So we have minus VE into 9, and this whole is equal to 0. Now solving this, we get the value of VE as 32 Newton. Since it is positive, the support reaction V is upward, so our assumption is true. Now apply the next static equilibrium equation, summation of Fy equal to 0. We have a sign convention is all upward force is positive and downward force is negative. So we have first upward force VA plus second upward force VE minus this downward force due to the UDL, whose magnitude is 12 multiplied by 3, this distance. Then we have this downward force of 30 kN, so minus 30, and this is equal to 0. Now by substituting the value of VE as 32 Newton, we have VA plus 32 minus 36 minus 30 is equal to 0. So from this we get the value of VA equal to 32 kilonewton. Since it is positive, our vertical support reaction VE is upward, so our assumption is true. Now let's apply the second static equilibrium equation, which is summation of Fy equal to 0 or summation of all vertical force equal to 0. So we have our sign convention is all upward force is positive and all downward force is negative. So we have our first upward force VA plus second upward force VE. Then we have this downward force due to the UDL, 12 kilonewton per meter acting for a distance of 3 meters. So we have minus 12 into 3. Then we have this downward force of 30 kilonewton acting at point D. So we have minus 30, and this whole is equal to 0. Now substituting the value of VE as 32 kilonewton, we have VA plus 32 minus 36 minus 30 is equal to 0. So from this we get the value of VA as 34 kilonewton. Again this comes out to be positive, so we have our support reaction VA also upward. So our assumption at point A is also true.